Welcome to our webinar on Modbus. My name is Erica O'Hara and I will be presenting today. As many know, Modbus is one of the most popular protocols used in automation today. And today we will go over Modbus RTU specifically. Okay, so our agenda for this webinar is to introduce all of you to Modbus. We will go over what Modbus is and how it got started. I will show you how to set up a Modbus network and explain the basic concepts of Modbus registers, addressing, and data types. I will then show you a few troubleshooting tools and lastly a few Modbus applications. If we have time, we will also answer any questions you may have about Modbus RTU specifically. I wanted to share a little bit about who we are. We are ICP DAS USA, and it was established in 1993 in Hsinchu, Taiwan. Later, the ICP DAS USA was launched in 2001. And benefits we offer are fast service, free tech support, free software, free fast shipping, and warranty. I also have with me Robert, who is our senior application engineer. Many of our customers know who he is. He's been here for more than 10 years and he's great. He's very smart. And if you have any questions, he will address this to you on the mic or through chat. So what is Modbus? So Modbus is a communication protocol used in industrial and factory automation, as you know. It operates via a master-slave architecture to monitor and control digital and analog I/O. Modbus has been a standard protocol in automation for 45 years. It truly has stood the test of time. Modbus was developed by Modicon in 1979. It was originally used in their PLC, but has been expanded to incorporate many other devices like HMI, sensors, other automation platforms. We will give you a basic understanding of Modbus RTU in this webinar. Modbus RTU is most often used in RS-485 networks, but it's not fixed to RS-485. The main reason why Modbus became so popular and is still used today is that it's open source and royalty free. There are a plethora of free Modbus demo programs in various programming languages and automation software platforms. Modbus RTU works using a master-slave architecture. The master device sends requests for data and write commands to slave devices connected through a COM port of the PLC, computer, HMI, or other Modbus master device. The requests are sent to an individually addressed slave device. Only the slave that the request is sent to will execute the request while other slaves stay in a listen state. A Modbus RTU network can have up to 247 slave devices connected to a single COM port. The Modbus master is typically a PLC, HMI, or industrial PSC, or industrial PC. The Modbus master will be traditionally programmed for a specific set of tasks and will use data from external devices to execute the steps it is programmed to do. The master will send requests for I/O status from remotely connected devices and based on its programming will control outputs actions to accomplish its task. A PLC is a perfect example of this. Let's say the PLC was tasked with monitoring a set of cold storage rooms. So each room will have a desired temperature and humidity requirement based on what is stored in that particular room. The PLC will monitor the temperature and humidity of the rooms with sensors and control the refrigeration to maintain the environment. It would also be able to monitor if the doors were left open or if the room were empty. Under these circumstances, it could either sound an alarm or adjust the temperature to save electricity. Modbus slave will typically be sensors, actual controller, or other peripheral devices. The slave device either provides data or control. The Modbus slave stay in idle mode until a command addressed to the specific RTU is sent. The slave will then process a request to either send back data or change the status of an output and send back a confirmation of the change. A PLC connected to some temperature and humidity sensors is a perfect example of this. So let's say the PLC was tasked with monitoring a set of cold storage rooms. Each room will have a desired temperature and humidity requirement based on what is stored in the particular room. The PLC will monitor the temperature and humidity of the rooms with sensors and control the refrigeration to maintain the environment. It would also be able to monitor the doors were left open or if the room were empty. It could save it could either sound an alarm or adjust the temperature to save electricity. Although other communication ports can be used like RS-232, RS-485 is the most commonly used port type for Modbus RTU. RS-485 used a twisted pair of copper wires to interconnect a series of devices to each other for up to 4,000 feet or 1,200 meters. Daisy chaining allows for a lot of devices to be interconnected using minimal amounts of wires and connections. RS-485 does have limitations. Baud rate and maximum distance are proportional. The higher the baud rate, the lower the maximum distance the RS-485 communication can travel. The wire resistance will degrade the communication, so wire type and resistance from devices must also be considered when wiring. RS-485 is also susceptible to electrical noise. Using repeaters, wiring hubs, and proper termination will usually help overcome these issues. Okay, there are 4 types of Modbus registers. Coils are digital outputs in PLC jargon. They are usually associated with relays. Their states are read as either on or off reading and can be controlled to turn on or off writing. Discrete inputs are your digital inputs, which are typically switches, proximity, or other sensors which can only be on or off. These inputs are considered read only since you can read the status of a sensor, but a PLC cannot control the sensor input. The sensor input is the status. Similarly, an analog input from a sensor is only readable. Normally, these would be a 420 mA signal from a sensor, a voltage or temperature reading. Since the signal is directly based on the sensor reading, it is read only. While an analog output can be controlled, is termed a holding register, since it holds a desired value which can be read or adjustable written to. Some sensor types are shown at the bottom, along with Modbus RTU protocol. We also offer solutions in these common protocols. It's a little blurry, but here's a typical Modbus register table. This is from one of our Modbus RTU data acquisition modules. This module has 10 analog input channels, which can be read with Modbus registered 30,001 to 30,009 or 40,001 to 40,009. There are also other readable or writable registers shown in the table. We will go into more detail about the address field in the coming slides. The slave devices will have a defined table like this, which defines memory locations where the corresponding data is stored. Some of these data are read only. These are your discrete inputs and analog sensors, while other data is readable and writable like DO and AO values. RS-485 communication interface and provides anti-sabotage sensor and door position detection function, which can consolidate the security of access control system and effectively enhance the service quality of management. Taking a closer look at this table, Modbus registers 30,001 to 30,010 contain a data form analog input 0 to 9. The values I just filled in some sample data. The short form address is directly derived from the Modbus address. This is an alternative form of the address. The 3 defines the type of register that it is, while the digits after the X are the memory location of the data. For instance, the 3X001 in an input register, which can only be read, not written to, the data can be found at memory location 1, while 3X010 is also an input register. Its data can be found at memory location 10, where a value of 100 is stored. Function codes are requests for data or commands to change data that a Modbus master will send to a slave device. Function codes are directly associated with the type of the register and the action shown here. Digital outputs can be read or written to. Function code 1 is used to read one or multiple digital outputs. Function code 5 is used to write a value of either 1 or 0 to a specific digital output channel. Function code 15 can be used to write to a series of sequential digital outputs. Digital inputs can only be read. They use function code 3 to read the data, and register numbering starts with a 1 or 1x. Similarly, analog output holding registers can be read to or written to. The difference is that the value that can be written to the register, instead of being 1 or 0, it is any number between 0 and 65535. Analog inputs are the read-only version of analog outputs. These will typically be a sensor or temperature reading. On the previous slide, we listed the function codes based on register type. Now let's see how they work. In the box shown at the top is a typical Modbus request for read. The example shows a request sent a Modbus device address 1 to read data from register 30,001 to 30,004. The slave address is 1 byte, which can be any value between 00 to FF in hex format or 0 to 255 in decimal. The function code 4 is used to read input registers. The start address is 2 bytes, which represents the offset from register 1. Since we are requesting data starting at register 1, the offset is 0. Finally, the Modbus register count is the number of consecutive registers of data you are requesting starting at the offset value. The resulting request of 0104000004 will give you the 4 analog input values requested in hex data format. The PLC or master will then interpret the value and scale. Let's go over a few more examples of function codes. This page contains at the top a read request for 5 coil values starting at 257. The resulting read command of 010101000005 is derived from 1 slave address, 2 function code for reading coils, 3 register offset of 257.1 equals 256, and converted to hex value 100. For the total consecutive register of data you would like to read. Next, I will show a write example using function code 5, write single coil. Now, note the difference in the string that the master will send. Since it is only for a single coil, the count is not needed. Instead, we need to write FF to change the coil status to logic 1. A write of 00 would change to a value of 0. There's also a 00 at the end of the Modbus command. The resulting command would be 01050100FF00. The previous examples show what is sent by the master to slave devices to acquire data or commands to write values or to outputs. Combining this read and write along with a typical PLC program, Modbus RTU can be used to monitor input and control outputs. ICP DAS has a plethora of Modbus RTU solutions. We also offer same tools that are useful in troubleshooting and improving Modbus RTU communication. Our Modbus Master tool is a free utility that allows you to pull Modbus devices connected to a PC through a serial port. Our TM7561 is a USB to RS485 converter that will allow you to connect to RS485 Modbus RTU slaves. Using the Modbus Master tool, you can read and write values to your Modbus RTU slaves to verify that your data is reading correctly and to make sure your sensors are providing the correct output signal for your application. Our Modbus utility contains a Modbus RTU master, which can send Modbus commands as defined in this presentation to your Modbus slave devices. You can use this utility to verify the correct responses from your slave devices byte by byte in hex format. You can also use this utility to measure command and response time. Unfortunately, we do not provide a slave simulator, but there are many out there. Two that come in mind are the ModRS Sim and CSCS simulator task. These can be used with our TM7561 to simulate a slave connection to your Modbus master. In instances where the slave devices have not arrived yet or you are doing a pre-installation simulation, slave simulators allow you to simulate data from slave devices and test programs and actions. Modbus TCP is the Ethernet version of Modbus RTU. It is also open source and is a very popular choice for many PLC and software manufacturers to support connectivity to. The same address structure and function codes are used in Modbus TCP. Because it is Ethernet based, it is much improved over Modbus RTU. It is faster and more easily scalable. Modbus TCP uses standard network equipment and can easily be added to an existing network. Data and control can also be done through the internet. Data logging from a PC. We offer Modbus RTU data acquisition modules which can be connected to a PC using a USB to RS485 converter. Our free Easy Data Logger software will allow you to connect to any of our Modbus RTU data acquisition modules to log data. This is ideal for laboratories, manufacturing locations, and cold storage applications. Since Modbus was created by Modicon to use with their PLCs, Modicon is now owned by Schneider Electric, but the protocol is open source and royalty free, as you know. Many manufacturers like Automation Direct, Allen Bradley offer communication ports which can be read and write Modbus data to HMI or remote Modbus data acquisition modules. Aviva Edge, formerly known as Indusoft, is a popular SCADA package similar to Wonderware that has drivers available for Modbus communication. Using this software, you can create control logic and monitor or data log. The software is best known to run on HMI or on a PC to act like an HMI to display and animate an application. Modbus is very popular in the industrial automation equipment and also in many industry. A wide variety of slave devices supports Modbus protocol. Devices like sensors, temperature, and process control and motion controllers can be controlled and monitored using Modbus. It is easy to implement since drivers and source code are widely available for free, and it does not require expensive wiring or infrastructure to add Modbus devices. We can now answer any questions that you may have, or we can, Robert, if you wanted to add anything additionally to this, would be great.
Okay. Does anyone have any questions?
Or you can raise your hand and I can unmute you and you can ask the question out loud if you like. Oh, I see one raised hand. Robert, I'm going to allow you to talk. Go ahead.
Can you hear me okay?
Yes. Hi.
Hi. I just, what I wanted to touch on is it seems like people that are new to Modbus have a tough time understanding the proper wiring for serial, like an RS-485 half duplex setup. Do you have any advice on best practices on how to wire that, and perhaps I'll call it a dumbed down instruction procedure for how to wire that?
Well, let's see, you do that by daisy chain. So essentially you're connecting all the data plus and data minus terminals separately. So like for instance, if you have one master device, you want to connect the data plus of the master device to the first slave device. And then from that slave device, you also connect that data plus to the next slave device and continue on until all the data plus devices are connected. And then I would start with the data minus from the master and go to the first slave and continue on. Ideally, you want to use twisted pair, but ideally you just need two wires anyway. So if you use two colors and they're short distance apart, there's not too much, chance for confusion. You do want to use proper wiring type because, as Erica mentioned earlier, the distance versus baud rate limitation depends on the wiring type as well, because the resistance of the wire, if you use improper wiring, like too thick of a gauge, then the resistance will be greater and you'll lose signal, signal distance, and therefore you may need repeaters. Did I answer your question, or do you have?
You did. I could probably speak to you after the presentation about more of a specific issue that we're having. I don't want to take up everyone's time here, but you did a great job explaining the general fundamentals of it.
Okay, sure. I mean, ideally, let's see, a picture tells 1,000 words, so I can, find many pictures out there that show daisy chain wiring. We have some in our manuals, but I think we need to simplify some of our documentation as well, because it can get confusing, and I understand how people get confused in wiring, especially when you can connect a third-party device at times, because I noticed that instead of using data plus and data minus, they use A and B, where B is the plus and A is the minus. So it's almost counterintuitive to how most people think, where the A should be the positive and B should be the negative, but I've seen it be the opposite. So you definitely need to pay attention to that, and biasing could also play a part in it as well.
Great, thank you.
Thank you, Robert. Richard has a question. I'm gonna allow you to talk, Richard.
Hello, Richard.
Yeah, speaking of the opposites, how do you deal with your registers are off by one? Is there a standard practice for that? Because that's so common.
Well, let's see. That has to do with PLC addressing versus what was the other one? I forget, but it's like ideally, if the register starts with like a 30,000, then it's zero based. If it starts with a 30,001, then it's one based. Within the Modbus command, most software packages, you just need to specify the actual register that you're writing to. So it'd be like the 30,001. And some of them actually have a little radio button or a choice to specify if you want it one based or zero based. Correct. I know that for us, we traditionally think of it as one based, but our Modbus master tool, which Erica showed earlier, allows you to do it based on specific bytes.
Right.
So go ahead.
When you get into industry, there is no uniformity. I'll guarantee you that. It changes depending on who the manufacturer is.
Oh, I agree. But normally you want to look for the very first register. If the very first register starts, like, say, 30,000, then you know it's zero based. If it starts with 30,001, then you have a good chance that it's one based. If they skip zero, that's on them. That's a bad practice, and that's not how it should be used. But ideally, I just look for the very first register, and that usually gives me the clue, or it's usually in the documentation.
Yeah, until you
And
build
worst
all
case-
your tables, get out to the field, and the device is wrong, and you have to export, shift the addresses by one, re-import them.
Oh yeah, that's very annoying. But actually, one other situation I ran into is there's companies out there that skip registers, and instead of allowing you to like pull, say, 6 consecutive registers, there's a
Oh,
gap
kill
in
you.
between. So then
Yeah.
you run into communication errors, and you try to troubleshoot, and then eventually you find out that they skip it, it's undefined, so that therefore you get the Modbus error that way. That's bad practice as well.
Well, the one I'm working with right now, it only allows you to pull 40 registers at a pull, okay? And then they have to start on the 40 boundary. You can't overlap the boundaries, even though there's registers there. Otherwise, you'll get comm errors.
Okay, yeah, that's based on the manufacturer. Ideally, I like Modbus tables that start at 1 and just have sequential registers, that make sense. And then usually configuration may be a different block, but those registers are less used. But the most common ones, ideally you want them to start at 1. If they start at some funky number, it may take some troubleshooting. Worst case scenario, just pull one register at a time. And we have that Modbus master tool, which you can send the request for data for one register, and then you can send a request for another register and see what value that register has. Ideally, you want to pull a value with a known register. I, for instance, like to find, the product name for our modules because it's always like the part number itself, or there's certain ones that maybe have the baud rate setting, or some other function that the value of, so you can verify it's the right value.
All right, the other protocol that wasn't talked about here, physical, is Modbus Plus. I've used that a lot in the past.
Okay, we don't have any Modbus Plus products, so that's why we tend to skip that. There's also Modbus ASCII, which is rarely used. I think I've run into maybe 3 customers over the 10 years I've been here that actually use it. In fact, I just recently read up on it because I was very rusty on it. But essentially, you just convert the what do you call it, hexadecimal numbers into their ASCII equivalent.
Yeah.
Okay, but yeah, Modbus Plus, we don't really have any devices for. I know that it's out there, and I haven't really gone through that either.
Well, it's being phased out. It's only on old stuff.
Oh, okay. Well, thank you so much, Robert. I have another question, Robert, about someone typed it. It says, can a variable be graphed with Modbus master tool or other program?
Our easy data logger can graph the Modbus register. However, it requires at least one of our modules to be connected, one of our data acquisition modules rather, to be connected to be free. As for a third-party data logging device, I guess you could use Indusoft, the free trial, to just graph it, but our Modbus Master utility and Modbus Master tool only show you the real time. It doesn't actually show a historical value. But the Easy Data Logger software can be used for that. But again, it does require at least one of our data acquisition modules to be connected. Otherwise, it'll have comm errors.
Okay, thank you so much for attending. For next month's webinar, I'm going to take in consideration all the answers that, oh wait, we have someone. Okay. What is done difference between Modbus RTU and Modbus ASCII?
Okay, the difference between those are the physical command strings that you send. The command and responses are going to be the ASCII equivalent of the Modbus RTU command. So for instance, if I think it was 32 was A, I'd have to look at a Modbus ASCII table. Let me just look at standard ASCII conversion table. I need to Google one
Um,
really quick. So let's see,
would you like to share your
ASCII.
screen, Robert, or anything like that?
No, it's okay. Let's see. I just want to find once I give you the right numbers. Okay. So a traditional ASCII table, you just Google, and I found one. So for instance, a command that starts with the 1, the ASCII equivalent would be a character number 31 in hex. So instead of specifying a 1 for that byte, you specify a 31. And then if the number were a 2, you specify a 32. So it's really a really complicated way to how would I say, have to think. But I guess in some programs it makes sense, but traditionally Modbus RTU is the way you want to go. Unless you have a utility that makes it easy or the software requires it. Because yeah, Modbus ASCII is no fun. I hope that answers your question.
Anybody else have any questions? Well, thank you so much for attending our webinar. We will, like I mentioned, we'll take consideration of all the answers that were from the poll, and then next, I'm not sure what our next topic will be in June, but I will let everyone know.
Okay, I think in the future we can do one where we actually go in more depth to the utilities and specifically do troubleshooting on some of the more common
Yeah, I think that would be great.
Modbus errors and problems.
Yeah, that's a good one.
It might be hard showing the wiring, but we could at least show the utilities.
Yeah. Okay, well, thank you so much, everyone. If you have any questions, feel free to shoot us an email at sales@icp-usa.com, and hope you have a good weekend. Thanks.
Okay, bye-bye all. Take care.